Welcome to qnawire.
All right, we've got to draw a Newman projection for this molecule. From the, let's call it carbon 1, 2, 3, 4, down the 3-4 bond. So one thing that I like to do is rewrite my substituents in their compact form. So I say I've got bond 3-4, and I've got a dash to a methyl, and I've also got a bond down and to the left to an ethyl, right? Because this is 1 carbon, 2 carbon, that's a bond to an ethyl. And then I draw in my hydrogens so they're explicit. Okay, now let's move on to carbon. Let's make that an H. Okay, so that's carbon 3. Now let's look at carbon 4. We've got a wedge. Once again, this is a methyl. That means we've got a dash to hydrogen that we weren't shown. And then we've got our, once again, a bond to an ethyl. Great. Okay, so now we're going to look down that bond, right? That's an eyeball, believe me. That is an eyeball. And so I'll just start from this carbon. And what it looks like to me is that I would have an ethyl pointing straight up if I were looking from this angle, right? This would be at the center. Ethyl would be coming up and somewhat towards me. Methyl would be going down and to the left, and a hydrogen would be going down and to the right. So I'm going to start from there. I'm going to say straight up is an ethyl. Down and to the left is my methyl, and down and to the right is my hydrogen. If you're having a hard time seeing this, how this ethyl would be straight up, consider that you can build a model of this with a model kit and then actually look down the bond physically. You could also imagine if you were standing, if you were a person, say, standing here, kind of scratching your chin, that in blue, you've got your left hand, and in green, you've got your right hand. If you were going to reach out and grab that methyl, which hand would you use? Probably your left hand. Oh, I'll do that in the other color so it's not as confusing. Probably your left hand, right? That's closest to the methyl because the methyl is closest to me. And if you're going to grab the hydrogen, you would use your right hand. And if you were to grab the methyl with your left hand and the hydrogen with your right hand, that ethyl would be like in your face, pretty much. Okay. So that's how I kind of can reason about that. Now we need to do the bond in the back. So to do the bond in the back, we draw a circle to represent the carbon that's in the back. And then we think about the relationship between these various groups. The first thing I see is that these ethyl groups are trans to each other, right? So that means if this ethyl is up, then this ethyl is straight down. That would be trans across that single bond. Now, it's not trans, like technically, it is trans, but it wouldn't be named trans because it's not a double bond, and there's free rotation about any of these bonds. So only in this conformation is it trans. I just don't want to cause any extra confusion there as far as naming goes. Okay, so ethyl is down, and then I can think again, if I could move my little dude over here, he's got his left hand would be close to hydrogen and his right hand would be closer to the methyl. So on the left and up, I should have a hydrogen, and on the up and right, I should have a methyl. So this is what I need to find. Now, they have not drawn in the methyls, so they just left these blank. That's fine. Now, let's see. Do we have one that's ethyl in the front up, hydrogen down to the right? Yeah, C. This looks like C.